In this video, I'm going to make use of one of the functions, that of difflib library, or can say difflib module, which is called get close matches. So we're going to import difflib. Then from that of difflib, we are going to import get close match. And how we can basically do this at an instant is just from this of our difflib. From this of our difflib, just like saying from this module, I want to import one of the function that is inside of it, which is our get close matches. This get close match is a function that is going to help us to get close match, and our items we are going to provide what is called an element, our target. We set our n to our default. That n stands for number of output we want, and then our accuracy, which is also called a cutoff. So let's dive in. So the first we are going to do is to come down here. Let's create of our list of elements that we want to get the close matches on. So I can say elements, which is going to hold it, going to be this. I can say that I write something like apple here, grape, I can say orange. I can also write maybe something like apricot. Okay, I think let's make use of this. So I can say let me write the grape too. Let me come down here. Let me create my target. I can say target. My target is to get, let me write apple. I know that inside this of our element here, nothing like apple exists inside here, but I want to check inside this of our element here. I want to check which word is closely related to this. The highest, like I said, the one with the highest accuracy closely related to this of our apple. I'll know that it is apple. So we're expecting when we set n equals to 1, we're expecting to get apple, and setting reducing our accuracy, we can get our desired output. So I can say here I can make use of matches. What is the matches going to be? I can say get the close matches. The first thing we are going to write is our distance. Inside we are going to put our target. That is target we are interested in. The element we want to check to whether it exists inside of our element list or element items. So here is going to be our target, and here is going to be our list, which is going to hold our elements. So the next thing we want to write inside here is our n, to set our n. Let's say we set our n to be what? Let's say we set our n right here. So we set our n to be what? Let's say we are interested in getting 3 outputs. Let me drag this up. We're interested in getting only 3 outputs. So also set our cutoff. Let's set our cutoff to 50%. I can say 0.5. This cutoff ranges from 0 to that of 1. 0 is 0% and 1 is 100%. And then when you're running 0.1, which is 10%, 0.2 20%, 0.3 30%. So this way we can set our accuracy. So down here we can print our. So when we print our match, because when we print our match, it's going to provide us with the element that has the best closely related. So let's run it and I will explain what is actually happening here. Let me click on it. You can see we're able to get apple, grape. Like we wrote grape 2 times. Yeah, so I wrote grape 2 times. Okay, let me just write something like banana here. Banana here. So let me run it. We're able to get 2 outputs. Why did we get 2 outputs here? Because when we set this to 50%, only the closely related matches that as of 50% is only this of apple and grape. Other one, this guy orange does not have a match. But what happened when we reduce the accuracy, which is this cutoff? Let's say I reduce it to something like 30%. Right now we're going to see more output on it because the accuracy has been reduced more to 30%. So let's run this. You can see I was able to get orange. Meanwhile, orange was not there yet. It was not there earlier. But to reduce it more and more, the more I'm reducing it, the more closely related matches I'm expecting to get. But this is not when in a real life scenario, your cutoff should never be below 50%. Setting it to 30%, 20%, means you just want to bring yourself to a whole lot of error that you do not want. But let's say in a situation where we want to get only one output, because here we're getting three. Let me drag this up. We're getting three output here, the closely related match, and this, remember that this output has been sorted in the way they are basically closely related. This output tends to be the highest, followed by this grape and this orange. So let me set this to 1, this n to 1, and remember that n is our output. Let me run it again. You can see I've got apple. If I set it to 2, we should be setting apple and orange. Let me drag this up. You can see we got apple and grape. So I set it to 3, it's going to be apple, grape and orange, like we have been getting. So you can see how interesting this was to do, rather than using our traditional way to compare two words together or two sentences together. Make use of the and and the comparison operator, and the comparison operator equals to operator to check whether they are the same, or whether some part of this particular word is in that of the other word target. So I think with this we don't need to do all those things. This get matches is going to basically go inside of this element and then try to find out which element that is inside there that matches of our target. Remember here, when you are writing anything inside, or when you are setting your elements inside here, make sure it's something that is in kind of a string format, something that I can check the length. If you put a number, it's going to be a problem, because number you can't check the length of one, become a serious problem. But if you close it in a quote, it can be handled. So that's basically what I want us to look at in this video. This might not be of much use as of now. When we start doing something really bigger than this, we are going to refer back to this and make use of this to understand how this guy actually works. So I think this is where we are going to end for this video. If you enjoyed, don't forget to hit the subscribe button, also like and share with your friends. I'll be happy to see you in the next video. Thank you for watching.